Alright, so welcome everybody to the last day of week 14. Got 4 weeks remaining in the semester, 3 weeks, and then the last week's finals week, but we don't do finals. But so, just competency exams, I guess, will be on finals week. On Wednesday, we talked about the Pokemon Part 2 assignment. I have posted my Pokemon 1 code, as I told you on Discord. I think you probably should just stick to your code, unless it's like super buggy or something, because you know it better. But my code is here in /temp/main.cc. So download that while you get a chance. I'm going to delete it before too long because I don't know. I kind of hate it when students wait to the last minute to start a project like this. So I can't tell you how much longer this will be up for. So copy it now. Okay. Like maybe I'll take it down, I don't know, some number of days before the deadline, just so that people are going to be encouraged to at least do something early. I don't know. How do you copy and paste files in Vim? If you want to copy the entire file, just cp copy /temp main.cc to the local directory. We'll do it. Dot means the current directory. Make sure you have the space there. And just copy this outright, and that'll do you. It's not Vim though. This is Unix. Okay. So I want to talk about a couple things. First of all, I want you to post screenshots of you loading your type system from disk. This is what we did in lab time on Wednesday. By the way, there's going to be a lot of lab time in the remaining 4 weeks in this class because we've covered all the major topics that we're supposed to cover in CSI 40 already, a month early. So it's one of the benefits of not doing midterms anymore, because whenever you do a midterm, you have to have a class to prep for the midterm, a class to do the midterm, and a class to review the midterm. And so we're 6 classes ahead just from doing competency exams. So we've covered basically all the major topics, and we're going to just be practicing them. We're going to be doing homework. We're going to be doing lab time. We're going to be doing quizzes. Basically rehashing, trying different things, using your knowledge in different ways, because that's how you get good. This is a very famous expression in the computer science world, get. And but seriously, I want you to get good at computer science. I want you to practice it. I want you to write code. If you're not good at programming, make sure that when you do the programming with your partner, you understand every line of code that's being written and submitted. Okay. That's why we're here. Yeah, we're here to get good. And I believe very strongly in the value of practice and you guys writing code. And that's one of the nice things about lab time, is that it gives you a chance to write code and not like have it be like a high pressure situation where you're gonna like fail the class if you don't do it. So I would like everybody to please post screenshots of your code loading the type system. Pokelemon Part 2. So here's the type system, and it is a tab delimited file. So you need to do a get line over and over and over again. You could do a string stream if you wanted, because this file is fairly nicely formatted. No, it doesn't have a tab there. Yeah, I'd probably use a get line to grab the whole line, and then I'd probably get line out of it to grab each individual string. Because remember, get line only gives you a string, right? Alternatively, you could probably use read library to do it as well. But remember to use S2F. 0.5 is not an integer. Don't use S2I. I means integer. Use S2F, not S2I. Okay. So Seguin and Otal did it. Let's see it from Ruiz, Marquez, Dumore, Masood, Westfall. Let's see your code from Wednesday. Everybody post your code. Okay. Show me what you got. Okay. One sec, you broke it. You've not done it yet? Okay. So, do you guys feel reasonably comfortable with what this is doing when it's mapping between a string and an int? Like, do you guys understand that? Like, each Pokemon has a string for their type, and if you really wanted to do it more properly, rather than having their type held as a string, hold their type as an integer. And rather than using 0, 1, 2, 3, 4, 5, 6, actually make an enum or an enum class for it. And so you wouldn't have to say if type equals 7. You know, you'd say type equals enum ghost or whatever. Okay. Good. All right. So let's talk about pointers. So pointers are the hardest topic we cover in CSI 40, and in part they're hard because they're not useful. Right? We used pointers for the Bridges Mountains assignment simply because that was the code that was given to us, and in fact a lot of people still use pointers, which is why you have to learn them. But none of the rest of the code we've done in this whole class have used pointers. Now, Pokemon Part 2 is a great example of when it's a good time to use pointers. What? Why would it be a good time? Well, so let's copy temp main.cc to here, then main.cc here. So we've got our Pokemon. All right. Battle mode. It's part 2. Okay, so let's just well, this code's working, so it should be fine. Okay. So it should be fine. Okay. So we need to pick a Pokemon and a move for Team 1. And we can do it like this. String name equals read. Please enter either a name or pokedex number for Pokemon number 1. And I'm using the read library again simply because it turns 3 lines of code into 1. And you can even do something like this. You can make it a const, which you can't do with normal CN. CN you can never read into a const, whereas with this, it actually works fine. Read library is simply superior to regular IO streams. Does read return auto? Read returns auto, yes. It's templated. So it looks at the type of the variable here. And sometimes, though, you have to specify the type, and you can do so like that, if you wanted. So the type has to appear somewhere. Okay. So that's going to read a name. And then what we talked about last time was how do you detect if because you can either type in Pikachu or you can type in 25. So how do you detect that? You look at the first character in the string, right? So if is digit, if name.length is 0, then die. Right. Just make sure they typed in something. Anytime I access an array or a vector using either square brackets or .at, I really like to make sure that I'm not gonna .at. Sure, it'll detect if you go out of bounds, but it kills your program, right? And so I prefer not. I'm just paranoid about this. Okay, so if is digit name dot at 0. And what am I paranoid about? What if there is no name dot at 0? When would there not be? When would that throw an exception and kill the program? I'm trying to read the first letter out of the name of the Pokemon. The first character. Could be a letter, could be a number, could be a space, could be a special character. When would that not exist? Somebody enters nothing. Yeah. Just hit return. Now, I think the read library actually makes you... I'm not sure about it. But yeah, I'm just paranoid about it. So rather than... anytime I use .add or square brackets, I sit there and think, like, do I know that there's going to be at least one letter? And this is a good habit for you all to get into. It's like, if you're reading the temperature value of, the user's entering a temperature value, can you guarantee that the temperature is going to be an int? No. They might enter 98.5, You should probably handle that. Can you guarantee that the temperature will be positive? No. Negative temperatures exist, And even if it was a system like Kelvin that has no negative numbers, the user might still try to enter a negative number. Like, you have to think about all the different possibilities. You have to consider all the angles and all the ways your code can go wrong, And so in this case, if they enter nothing, this name.at here would throw an exception and kill the program. And so in reality, I would probably not die. I would probably be like, no, you need to enter a Pokemon. Come on, help me out here. But I'm just writing a little demo code for you. So if it is a digit, then we're going to have a Pokemon 1 and Pokemon 2. And these are just blank, empty Pokemon right now. We're going to read them from the Pokemon database in just 1 second, but we're going to have to select them either for Pokedex number or for name. Okay. So if they type in a number, search on Pokedex number. Now, we're going to have int Pokedex number equals stoy name. Hopefully you guys are all familiar with stoy by now, right? If somebody enters nothing, your return's missing no. Yeah, it's actually what's going to happen, all right? Like, P1 and P2 are actually missing no right now, because there's a special entry that I put into the Pokemon database called error, and that's just Pokemon 0, because there is no Pokemon 0 in the Pokedex. And so if you ever have like a blank Pokemon like this, its name will be set to error. And I do that so that in case I screw up, it'll be very obvious. Hello, my name is Error. It's a character from Zelda 2, right? Okay, so you guys all get what's happening here. So if the first digit of the string they type in is a number like 2, then we're going to convert that whole number into a Pokedex number. Okay. So Pokemon 1 is going to be equal to Pokemon DB .at Pokedex number. Again, there's a .at here. My mind immediately goes to think about this. How could this go wrong? How could this go wrong? Can Pokedex number be a negative number? Overflow? You mean like out of bounds? Yeah, it could go out of bounds. But let's talk about that in a sec. Can Pokedex number here be a negative number? How could it be a negative number, Mitchell? What would the user type in that would cause Pokedex number here to be a negative number? Because if they typed in -5, the first character in that string is going to be the hyphen, right? Yeah. So I don't think we actually need to worry about negative numbers here, technically. But Niles is absolutely correct when he said overflow. I think he meant to say if the number is outside the range of Pokemon we have, right? So if we if they typed in 5,000, we don't have 5,000 Pokemon. Maybe there are. How many Pokemon are there these days? They've come up with a lot of random ones. 900. Okay. Yeah, so 5,000 would be out of range. Okay. Yeah, okay. So to go out of range, right? And so that we should probably, like, check. You know what I mean? Like, probably check for that. Not to mention a literal garbage bag. Is that Trubbish or something? Yeah, like at a certain point, it's like you just know that all the people are like sitting there in like Nintendo / Game Freak offices, like, all right, what animals have we not turned into a Pokemon yet? What about a whale? No, we got Whalmer. Damn it. What about a dog? We've got multiple dogs. Let's do another dog. Okay, let's do this. There's a Pokemon that's keys. Yeah, jeez. Yeah, anyway, so Pokedex number. Yeah, so we should probably check to make sure it's within bounds. And again, .at will do that for us. It'll kill the program if it's out of bounds. But and somebody might rightly criticize, like, you don't need to use .at if you're using, if you're bounds checking, and that's true. Technically, if we're doing the bounds checking ourselves, we could use that. That would be fine. It'd be a fraction of a millionth of a second faster. If I was writing the code, I'd probably use square brackets just for that reason. But it's a bad idea for new programmers to use it. Just because you're going to screw that up, you're going to forget it, there's going to be something. It's not like you're doing this in a loop. It's not like you're doing this a million times a second. You're pulling out a Pokemon once, right after the user has like spent like the last 10 seconds typing in Whalmer or whatever, right? So the extra 7 billionths of a second to use .at versus square bracket is utterly irrelevant. It is utterly meaningless. So just use .at for everything, especially in Seaside 40. The lantern. I think there's a couple lanterns, are there? There's like Litwick and there's one called Lantern. Oh, no, that's a fish, isn't it? And then like the Yamask kind of looks... No, I don't know what I'm talking about. That is ridiculous. That is absolutely ridiculous. Chandelure. I don't know. There's got to be just like... I would just love to watch those meetings where they're just like brainstorming ideas for new Pokemon, All right. Let's do a coffee Pokemon. Let's do a Pokemon it's a remote control Pokemon. A paper. Let's do animated paper as a Pokemon. I don't know. Trubbishes, yeah. Okay. All right. So so we need to bounce check this, right? So if Pokedex number is greater than or equal to Pokemon DB dot size, then die. You guys all with me on this? So it's a vector. Vectors are contiguous in memory. So there could be an issue with Pokedex numbers not corresponding to their slots in the vector, and I'm just not going to worry about that right now. Okay. A pile of gears, yeah, Clink or whatever it's called, or Clink and Krong or something like that. Yeah. So strange. Bronzor, the Bell Pokemon. Okay, so let's just do this. See out. Loaded. P1. Do I have a double lifter operator defined on it? Do I? Did I do that? Check me out. Did I really? No, I don't think I did, actually. Nope. So we'll do friend OStream reference operator double left arrow OStream outs const Pokemon P see out p.name. Let's print out the name. Colon or something. And then I don't know how I want this formatted exactly. Let's do this. Name, index, HP. You guys see what I'm doing here? I'm just making a little double left arrow operator here. Attack. P.attack. And I probably shouldn't be using double. Wow, I actually got a special double less than sign. Yeah, it's not the kind of thing that I expect you to have memorized. It's just something I've done enough times that I've memorized it. Inline is not as efficient as that. That's actually faster. Again, are you going to be printing out 1 million Pokemon a second? No, then who cares? My code is 9 billionths of a second faster. And this is actually a good takeaway point, by the way, is if your code's not running in a loop, it very rarely matters how fast your code is. Unless it's like calling code in the loop or something, but there. Okay. If your code only runs like once, like it doesn't matter usually. Speed. All right, so let's run this. Do you want to use a Gen 1 Pokemon? Yep. All right, Pokemon battle. Please enter the name or Pokemon number. 25. It loaded Raichu, whose index is 26. Ah, that's a good point. All right, so let's fix that. Do you see also why I printed it? Right, because the error Pokemon takes up the first slot, and so all the indices and the pokedex numbers aren't going to correspond to 1-to-1. So I could like subtract it out or something, but given the fact that we could just be using like Galarian Pokemon or something, I'm just going to do this more proper-like, and we'll do that, and we'll get rid of view actually, and we'll get rid of view, and okay. So we're going to say for every const Pokemon by reference. Try to use P1, P2 for every Pokemon P2 in the Pokemon DB. So we're gonna search through the entire Pokemon database, trying to find a Pokemon whose index number matches the one typed in. Right. So the user typed in, give me whichever Pokemon has index of 25. Now, it's at this point where you might say, well, why aren't you using a different data structure than a vector? For example, for your Zybooks, you're probably learning about sets and lists and maps and things like that. And the answer is yeah. It's actually much faster to search for a Pokemon if they're indexed on their index using a set or a map. That said, how often do you load a Pokemon from the database? Once. So unless you've got like a million Pokemon or something, like I'm not gonna sweat it. Like I basically, but you're doing 800 extra operations. That's true. That is true. And if it ever bothers me, I'll change it. Leave obvious optimizations so you can make them later. Yeah. Okay. So all right. So if the P1, no, what was it? Pokedex number. So I don't want to call this P2. I'm gonna call you Poke. All right. So if Pokedex number matches poke.index. So what we're doing here is we are going to search through the Pokemon database to find the Pokemon with the given Pokedex number. So if the user typed in 25, what we're going to do is we're going to say for every Pokemon in the Pokemon database, if I could spell Pokedex number right, if 25, whatever Pokedex number they type in, matches the index of that Pokemon, and remember, whenever you load classes, they should be done by const reference unless you need otherwise. Okay, so by using a reference here, it doesn't copy all the data out. It just uses a pointer behind the scenes, and it's much faster to do it this way. Or you can use an ordered map, yeah. Okay, so if we ever find the person who matches, then we will set P1 equal to Poke, and we're done with the loop. So we could not have, this would actually be fine. But once you found the Pokemon, you don't need to keep searching through the rest of it, right? Like once you found Pikachu at index 25, you don't need to go through the remaining 900 Pokemon, right? Just end it early. Break's useful for. Okay, so let's try this. Warning, ignoring the return value. Oh, it's so stupid. So stupid. And it's going to give me an unused variable set but not used. Yeah, I know. Seven plus 2 times n divided by 2 equals order in. Yeah. Yeah, we're doing an order in search when it could be order login. Or order 1 with a hash table. Okay, so use the gem on Pokemon. Yep. Alright, Pokemon battle time. And index 25 is Pikachu. We got the index, the HP, the attack, the defense, the speed, the special, type 1 electric, type 2 nothing. Cool. So that's how you can search through a database and load a Pokemon. And then you'll do the same for player 2, right? It's the same code, copied and pasted. And then I will let you write the code to search based on name. So if they typed in Pikachu, I'm not going to tell you what would change, but it's going to be pretty close. Okay? You guys think you can do that? It's like given this code here on how to search through a vector to find somebody who's got a matching number to the index. Do you guys think you can do the same thing for the name? Because this is really what computer science is about. Computer science is about finding people that have done something similar to you and copying and pasting it and modifying it. It's not all of computer science, but a good chunk of computer science is like go on to Stack Overflow, find somebody that's done something vaguely similar to what we're doing, and you have to understand it because the code you're going to write for searching on name is not going to have a string to integer in there, right? And in fact, when students blindly copy and paste, like, it's a sign to me they don't understand what's going on, because you can't just blindly copy and paste. You have to still understand what's happening, right? So if name equals poke.name, I'm not going to tell you that you're right, but you're right. But there's no stoy, right? Because you're searching on a string, not on an integer, right? So, that's what that's like a skill, to be able to intelligently look at existing code and adapt it to your needs. That's a really, really, really important skill in computer science. Mr. Bell, you want to back me up on this one? Like, you're learning TypeScript for the first time, and you found a way to split a string based on tabs. Do you include something to use read? Yeah, you have to hash. That gives you the access to the read library. Need good problem solving skills. Yeah, problem solving is important, but also most of what I do is looking at other people's code and changing things. I actually make my own references a lot. Yeah. It's like if you look at like programming memes, like they just say, oh, it's just all about downloading code from Stack Overflow and hoping it works. No, like, that's bad computer science. Good computer science is downloading code from Stack Overflow and understanding what it does. So you don't have to guess if it works or not, but you actually understand what each of the lines do. And when you come to a line where it's like, I'm going to copy and paste this to do search by name instead of search by number, you know enough to take that line out, right? Because you don't need to convert Pikachu to an integer, because it's not an integer. That's the key mental habit of a good programmer, is they actually understand every line that's going on. And sure, like, I learn bridges by looking at the bridges source code. They send me their examples and I look at it. I wouldn't be able to write any bridges assignments from scratch if you just gave me a blank notepad. I mean, maybe by now I would, because I've done so many of them. But the first time I started writing bridges assignments, like, I could not know the order of when do I call this function, when do I call this function. I need to see example code. I need to see somebody work it out. And once I've seen somebody work it out, I can modify it, and I can adjust it and adapt it to my purposes. This is the key mental skill of a good programmer. Yeah, it's copy and paste and modify, but also understanding. Folder references. Yeah, I've got on my computer here my documents directory. I've got a programming directory, and you can see in here I have all of my classes broken down. I have a folder for every class. I've got various students have sent me various homework assignments at different colleges over the years, and so I've seen homework assignments from Berkeley and Santa Cruz and Irvine, and I kind of look at what they're doing so that I can prepare you guys for it. So like, if they require you to know about linked lists, well, then I'm going to teach you about linked lists. That's in fact the Zybooks this week. You're going to learn about lists. Okay. So I'm not going to do search by name for you, and I'm not going to do I guess I can do loading Pokemon too. It's pretty much the same thing. All right, so mark x, mx. It sets a mark, so I could always go single quote x and jump back up there. It's nice. I'm going to do y single quote x and copy all of that code. Shift P to paste it above. And then for Pokemon 2. And all this code will be the same, except that is P2. Okay. Anytime you copy and paste code, you should do a once over on it and make sure that you're not going to have any copy paste errors like I had there. I was talking, and I didn't see that there was one more P2. So every time you copy and paste your code, you need to scan it. Otherwise, you get what's called a copy paste error, and that would be bad. Okay. Reading documentation is very important, yeah. But also documentation oftentimes is very lacking. Like, they don't tell you what order things should go into. Like, they'll describe a function, and they'll describe another function, but sometimes one function needs to happen before another function, like an init function that initializes something. That has to happen first, you know? And, you know, their documentation is usually at kind of like the function level. This function does this. Okay, cool. But in terms of like, you have to do, you know, this, then this, then this, then this. That's what example code is really important for. Like, here. Let's look at some documentation. Okay, let's look at some documentation. TCP_stream. It is a TCP/IP stream socket with timeouts and a polymorphic executor. Wow, that is such a great description. I'm sure all of you guys understand what is this for. What does it do? Types. Okay, it's got an endpoint type, an executor type, a protocol type, a socket type. All right. It's got a function called rate policy. Okay, let's click on that. What does rate policy do? It returns the rate policy. What the hell is a rate policy? Okay, cool. Here's the thing. Rate policy. It returns a rate policy. And there's a const version of it. Cool. What is it? Why would I use it? Where would I use it? What order do I use it in? Read some. Oh, it reads some data. Okay. All right. Let's find out more about read some. It reads some data. And here's the function header for it. It takes a size, probably the amount to read, and a mutable buffer sequence, whatever the hell that is. It's not... Okay, there it is. We can click on that. Oh, that actually has a little, like a couple paragraphs. How amazing. But it doesn't... Okay, so you can criticize document a lot. You know, close probably should come after open. Like, you probably guessed that. But, like, what order do these functions take place in? I need to see demo code. I need to see example code for that. Okay. Here's the header file. Okay, it doesn't help me. None of this helps me. You know, I need to see somebody work out a program using it. And then once I do that, I'm like, oh, it's pretty easy. You know. I usually look for documentation sites with examples. Yeah, this is Boost, which is like the minor leagues for the standard library, you know, which have the best examples. Yeah, like, very true, very true. Like, ZMQ actually has good examples for their networking library. But Boost TCP Stream, that library that I'm showing you, is actually the easiest networking library that I've seen. And it's just horribly, horribly documented. They do have some example code, and 2 of the 3 examples don't work. They won't compile. Yay. It's okay. So let's come to the point for today. So we've read in Pokemon 1, Pokemon 2, and then we'll do our moves later. Who cares about it? Yeah, Java was pretty bad about that. Like, they would leave up old demo code for like Java 1.0, and you try it out, and this is not good code, usually. I don't know. Okay. So, let's do this. One of your letter grades is figuring out which of these Pokemon is faster. I'm not going to do this for you. I'm just gonna say Pokemon 1 goes first. Okay. So I'm just going to make a variable called P1 turn. That means it's Pokemon 1's turn to go first. I'm not going to tell you guys how to access, for example, P1.speed and compare it with P2.speed. I'm not going to show you guys how to do that. I'm just going to assume that player 1 is faster, because that's a letter grade. It's on you to figure out who goes first. Okay, so so we'll do a while loop, while true, and this will be like fight unto death, something like that. So they'll keep fighting until one of them dies, and when one of them dies, it breaks. But I'm not gonna do that because again, it's a homework assignment. But I just want to show you a cool little trick using pointers, and then I'm going to give you the rest of this class to work on this. Okay, and don't just like log off. I mean, you can log off, it's fine, but like don't just like leave. Like actually work on it. Like the reason why I give you lab time, and I gave you lab time on Wednesday, and I'm going to give you lab time today, is so that you work on it prior to the deadline, you know. And then if you get stuck, you have plenty of time to do it. If you come to me in office hours on Wednesday prior to the deadline, like it's probably too late at that point, you know. I mean, last minute stuff, your code's not compiling for some reason, like yeah, I could probably help you with that, but you need, like anything major, it needs to be worked out at least 24 to 48 hours in advance. So here's the trick. So here's the trick. I'm going to say Pokemon pointer attacker equals P1. Pokemon defender equals P2. And then if it's not reference of P1, reference P2. And then if this is assuming it's player 1's turn. If it's not, then I do it the other way around. So if it's player 1's turn, then it's P1, otherwise it's P2. Player 1's turn, it's P2, otherwise it is P1. Have you guys seen the ternary operator before? This is like an if statement kind of thing. So question mark, yeah, question mark. It means if P1 turn is true, then it evaluates to this. Yeah, it looks horrible, doesn't it? It's like one of the most ungodly, ugly ass things I've ever seen in my life. But it's cool because it allows you to do stuff like this. Without this, you'd have to write. Let me write the equivalent code. If P1 turn attacker equals P1, else attacker equals P2. So these 5 lines of code here is the same as that, or actually technically the whole thing. So if player 1 turn is true, then this is an expression. So the ternary operator is an expression. An expression is anything that can go within parentheses, right? And so this whole expression evaluates to P1 at P1 if P1 turn is true. So if it's player 1's turn, the attacker is player 1. Okay. Otherwise the attacker is player 2. And then for the defender part, it would be basically the same thing. Actually, we can do this. Okay. You guys understand? So these 2 lines of code are the same as these lines of code here. Are there any limits to using the format? Not really. It just is sort of embedding an if statement in the middle of an expression. So an expression is anything that kind of go on the right side of an equal sign. All right. So rather than having to kind of write it out this way, and the benefit is that you can declare the variable on the same line. If you were to do it down here, Pokemon pointer attacker. If you were to do it down here, the variable goes away. The variable goes away immediately, right? So if you were to do it, you'd have to do this: Pokemon pointer attacker pointer defender. So you'd have to make the variables first and then set them later. And I don't like doing that. I actually like setting the variables with the right value when they're made. And for some types, you can't even do this, right? Some types cannot have no value. And like these things called references. References always have to point at something. So, yeah. You guys understand? All this code down here is the same as this code up here. It's a ternary operator. So let's just do this. Cout p1 turn, and let's use parentheses. P1 turn. If P1 turn is true, we'll cout hello world. And if not, that's the colon. And if not, we'll cout goodbye world. See that? So if it's player 1's turn, it'll print out hello world. If not, it prints out goodbye world. Or to make it a little more, little neater. Let's do this. We'll cout if it's player 1's turn, we'll print out player1.name. Otherwise, we'll print out player2.name. You guys see that? So if it's player 1's turn, it'll say Pikachu's attacking. And let's say Pikachu's fighting Rattata or something. And then if it's player 2's turn, it'll say Rattata is attacking. I don't need to copy and paste my code, right? I can just embed the thing into the thing like that. Make sure you use parentheses for order of operations issues. So if P1 turn is true, then attacker will point to P1. If it's not, it points to P2. And so this is why I'm saying that pointers are useful. Is you can have a pointer pointing at, attacker could be pointing at P1, defender would be pointing at P2, and then on the next turn, they switch, right? Because at the end of every turn, you're going to say something like this, right? P1 turn equal to not P1 turn. The end of every turn, switch who is attacking. Defending. Right? So that's going to be the loop. So in the loop, it's going to switch back and forth. Rattata's attacking. Pikachu's attacking. It does look gross, but it allows you to write things like this without having to copy paste code, and you don't even have to have an if statement. You can just like embed the if statements into the middle of something. And that's kind of cool. So, how do you use a pointer with a class? Learning point for today. An object means a variable of class type. Okay. You do it like let's just leave that up there as a point of reference. Arrow operator. The arrow operator is the same thing as dot, but for pointers. So what we say is attacker points to name, or attacker arrow name. Okay. So attacker.name is attacking, and defender.name, except with a pointer you don't use dot, you use arrow. In Java it's the same thing. It's dot for everything. Okay. You guys see that? So this is essentially the same thing as like p1.name. That dot is used. Dot operator is used with a regular variable. Attacker points to name. Arrow operator is used with pointers to objects. You guys see that? So P1 is just a regular variable, so use dot. Attacker is a pointer, so use arrow. Questions? That's our big learning point for today. No? Completely clear? You love pointers now? Pointers are useful and fun. Yeah, there's nothing wrong with pointers. You just kind of need to get familiar with them. It's like everything. You know, algebra is tough until you get used to it, you know. So let me run this, and maybe that'll help. So regular Pokemon, a battle between background and Pokemon.text. Who should we fight? Tentacool versus Seal. It's a jellyfish versus Seal matchup. Okay, so 72, it loaded Tentacool, and 86 is Seal. And so you can see here, it switches back and forth between who's attacking, who's defending, right? So Seal is attacking, Tentacool is defending. Tentacool is attacking, Seal is defending. Tentacool is attacking, Seal is defending. Seal is attacking, Tentacool is defending. You see that? Right now it's just a infinite loop, obviously. But that switches who's attacking and defending. And so rather than most people in previous years wrote all the code for this assignment with all the like grab the type information and figure out the single type attack bonus and load this type system and the attacker's offense, the defender's defense. They wrote all of it twice. And that hurts my spirit a little bit. When you write like one of these big complicated functions and you've tested and debugged it, and then they write it again. Why did they write it twice? Well, what if player 1 is attacking? What if player 2 is attacking? And so they wrote the exact same code, switching all the P1s to P2s and P2s to P1s. And let me tell you, did they forget sometimes? Yes, they did. And they would change it twice, or they'd forget to change it at all. And then you'd have Pikachu punching itself in the face, and it's a giant, colossal mess. Much, much better to do it this way, right? Where just at the top of the code, you figure out whose turn is it to attack, whose turn is it to defend. Use a pointer, either have attacker pointing at P1 or attacker pointing at P2, and then the defender is the other one. And then you just use attacker for everything and defender for everything. Surprise Pikachu face. What? Why am I hitting myself? So it really bugs me when I have to copy and paste code. For a number of reasons. First of all, it's extra work. Because you have to go through everything. Second, it's longer to compile. Third, it introduces copy-paste errors when you forget to change something. Fourth, if you have a bug in one of your versions and you fix it, it's still going to be in the other one, and you might not even notice it. So you have to remember to fix things in every place where it's copied and pasted. Oy vey. No, you do not want to copy and paste code if at all possible. I mean, from Stack Overflow to here, sure. But like in your own code, if you write a giant block of code and you copy and paste it, there's probably a better way. There's something called dry. Just don't repeat yourself. Okay. So I know I've said it before, but I'll say it again. Don't repeat yourself. All right. No one can faint. This is torture. Yeah. So Valdez, what's confusing about this? So we haven't implemented the combat, obviously, but I just wanted to show this to you. No, I meant like, confusion attack, yeah. Right. So this is how I would recommend you write your code. And then you could do things like, I don't know, damage done. Attacker points to attack divided by, remember to convert to a float. Anytime you do a division, you should immediately think, do I want to do integer division or floating point division? Okay. Or you use double if you want. Times, you know, times stab, times type, times power of the move. I'll just do this. So, just pure ratio of offense to defense. I don't know. Right. So move power 1, no type system. So, damn it. So, let's assume the attacking move. Let's say the attacking move is a power of 10. Let's say the attacking move is a damage of 10, and so and there's no type modifiers for like fire versus water, any of that stuff. No stab, nothing. This is, you know, how much damage an attack would do. So if Pikachu has an attack of 100 and Rattata has a defense of 50, it'll do 20 damage. Because it's a ratio. It's the ratio of attack to defense that matters. Okay. Does Stoof work on doubles? Stod. Yeah. Got a Stod for it. All right. And then if we want to damage somebody, right? Then we would say... defender points to HP. Minus equals what? If we want to reduce the health of Rattata after Pikachu punches it in the face, how do we reduce the health of Rattata? Defender points to HP minus equals what? How much damage did we just do to it? Damage. Yep. So, see out. Do you see how I'm using the arrow operator? I'm just kind of writing a little bit of code here just so you can see how the arrow operator works. Right? So, defender points to name has defender points to HP remaining, and if defender points to HP is less than or equal to 0, see out defender points to name faints, and we will break out of the loop. Okay, so this is actually a working combat system now. So the attacker will punch the defender takes damage. If the defender dies, it quits. Otherwise, it prints out Rattata has 40 hit points remaining. Then it switches Rattata and Pikachu. Rattata punches Pikachu. Then Pikachu punches Rattata, and back and forth until one of them hits 0 health, and it's game over. This is basically what you have to do for your assignment. Right? Just pulls out the snipping tool. It'll be on YouTube. So, I should probably compile it, huh? That's a classic blunder also. Why is it not working? Well, you didn't compile. Alright, so Rattata is 19. Okay. So we want to have Pikachu fight Rattata. Oh, Beedrill. Did I do that wrong? Beedrill. Oh, wow. Rattata's 19, sorry. Okay. 25 and 19. Okay, Pikachu is attacking, Rattata is defending. Damage done, move power 10, no type system modifier, 15 points of damage. Why is it 15 points of damage? Because Pikachu's attack is 55, Rattata's defense is 35. 55 divided by 35 is 1.5. The move does 10 damage, so it is 15.714 damage. Okay. So 15 damage gets knocked off Rattata's health. Rattata then attacks back and does 18. Its attack is 56. Pikachu's defense is 30, so it does a little bit more damage. Pikachu then retaliates, punches Rattata for 15 more damage. That drops Rattata to 0, and Rattata dies. Okay. And again, if you're one of the people that's like, why are we writing a video game? Well, I don't know if you know this, but like algebra and data structures and loading things from disk are all super common tasks that we do in computer science. And so, while yeah, it's fun and you're actually implementing the rules for Pokemon. While it's fun, it's also exercising all of the skills we need in this class. And these are all skills like Mr. Bell about to go and rate my professor. I know, I'm a little salty about that. Still. A lot of the criticisms, by the way, are valid. Like, Kearney talks about random stories too much. Yeah, that's fair. Kearney posts memes. Yeah, that's also fair. Kearney posts bad memes sometimes. Oh, what did you say? How dare you, sir? Greta Thunberg meme. Criticize my memes. Yeah. As you should be, yeah. Isn't there some variance of damage the moves can do? Not in our system. No. There is accuracy, and so you can roll to miss if you want, but the way we're implementing it, every move will always do exactly the same amount of damage. Criticizing a man's meme is worse than criticizing his mother. All right. His memes are hit and miss. What the hell did you just say to me? Okay. Yeah, but this assignment is actually good for you. It's going to teach you about pointers. It's going to teach you about loading from disk. It's going to teach you about maps, algebra, using the arrow operator. Yeah, it's good. And these are all very useful skills. None of this is. It's going to teach you how to make money. Yeah. The goal of this class is to get you to a certain level of competency, and then after 41, you're ready to get a job as a junior programmer. So learning how to program is 2 semesters. That's it. Computer science is a 4-year degree, but learning to program is a year. So you'll have Cromwells in your classes for the next 3 years. That's funny. And thank you for that. I appreciate that, Cromwell. Yeah, I don't know. To me, video games are actually, they integrate all sorts of different skills. But maybe for the next one we'll do like some physics simulation or something like that, just so you can see that computer science is not just for video games. Do like a bridges heat transfer assignment and silence the critics that way. All video games are code with fun. Yeah. Bella's been here for 4 years. Come for the learning, stay for the stories. Yeah. I'm trying to be a video game developer, so this is really interesting. Then take IS 50. Yeah. Wait, you take 40 after 41. The sequence is this: 40, 41, 26, 45. So we have set up a 2-year program here. I will teach you all 4 classes in a row, and we do that deliberately so that you kind of come to know my teaching style, and you get used to the server and stuff like that, and how my autograder works. Lawden is on the opposite cycle. So if you took CSI 40 in the spring, you would have it with him. Then he would teach you for 41, and then he would teach you for 26, then he would teach you for 45. And so you stick with the same professor, and you get to learn his autograding system, which is different from mine. And the dude actually has a doctorate in part from writing autograding systems, which is pretty cool. I need to actually, once this damn pandemic is over, finally, I need to actually take the dude out to lunch and find out how he does his autograding and stuff, and how do you do plagiarism detection? Because we have our algorithm, and he's got his, and I want to learn about it, So Simple 2D kinematics. Oh, we could do that. Yeah, like we could do some inverse kinematics maybe. Like if you have a robot arm and you got a shoulder and an elbow joint and a wrist joint and finger joints, and there's an apple here. I want you guys to solve, how to move the arm to grab the apple. That would be a fun task, right? You guys would have fun with that. No, I literally don't worry about the complainers. Mr. Bell, have you seen IK before? So with inverse kinematics, you just specify an angle that the shoulder, each of the joints will be at. With inverse kinematics, you're given a point that the final bone or joint has to be at, and then the system has to figure out the different angles to get there. Okay, and you're given constraints on, like, your elbow can't bend backwards, things like that. So like if you have a robot and you want the robot to pick up the auto part, that's a point in space, XYZ locations. Your robot arm has different things that get set, and so there's the thing on the conveyor belt and it might be moving, and the thing needs to reach down and grab it. Right? That's inverse kinematics. That could be a fun assignment. Could have robots for 8 years. Yeah. Well, robotics is another thing. It's like video games. It's like, in order to do robotics, you learn about a lot of different things, right, Margaret? Like, were you at Buchanan with Paul Lake and that robotics team there? I talked to Paul a few times, and his kid was actually, I think, with you, Mr. Bell. Lake, Evan Lake. Oh, you competed with him. Yeah, but like Margaret, I'm talking about. Like, robotics is a great way of integrating all sorts of different knowledge, right? You have to learn like mechanical engineering and programming and problem solving and electronics, and like it's actually a great educational field, just because it teaches you a lot of different things. Evan Lake, yeah. So maybe we could do this. This could be fun. It's just a matrix of partial derivatives. You guys should be able to do that. That should be like, I think we all understand what's going on here. This is clearly CSI 40 as it was meant to be. I'm pretty sure, right? Recall that theta is equal to the inverse of the function of e, and the derivative of e is j times the derivative of theta. Like, I mean, you knew this already, but we're going to recall this, just as a friendly reminder. So. That's it. I'm just messing with you. But physics assignments are pretty fun sometimes too. Okay. So for the rest of the class today, I would like for you to try to do this, and by try, I mean like actually do it, not just try. Do or do not. There is no try. Like, do this, right? You know what I mean? Like, try to get search by name working, as well as search by index, and also get the pointers working like this, so that you don't need to repeat yourself, because it drives me crazy when I see like 1,000 lines of code and then students go copy paste, and then they or they go into the help center like, how do I copy more code that fits on a screen of putty? Because I can select a screen at a time, but I can't select I'm like, oh. if you're and students are like, shrink the font down to two point, and then you can copy 500 lines of code. I'm just like, no, don't do that. Please don't copy 1,000 lines of code at a time. No. So this year, I'm just telling you, this is a much nicer way of handling that problem, right? Did you say wait to the last minute? That's exactly right. But no, just don't, like, and I grade these things, right? And then I'm sitting there scrolling through the code. I'm like, why is there a bug only when the second Pokemon's attacking? Oh, I see. It's a copy-paste error. You know. So, let's do it this way. Get a little bit of experience with the arrow operator. Okay. Get a little bit of experience searching through a vector by name, by number, and do a little bit of algebra. You should be able to get a lot of work done with your partner in the next 45 minutes or so. Okay. If you're copy pasting something, it probably should be a function. Yeah. And if you've got 500, 1,000 lines of code all in one giant block, it's probably could be refactored, you know, some way. So that's our class for today. Go ahead and implement and CSI 40 requirements, PhD in quantum physics. Yeah, it's just an array of partial derivatives. That's all. I don't need to remind you. This is just review, but okay. All right. So that's it. That's it for today, guys. And I will see you on Monday. All right. Peace out. Find a new particle. Yeah. What was it in Tony Stark was like, you have discovered a new element. Yeah. None of the science in the Marvel universe makes sense, but, you know. Okay. All right. So that's it for today. See you guys.